YOLO everyone! So ready to get the Trigonometry Junior? The reason why I call this Junior is because you're going to see another trigonometry in the attendance functions in grade 12. That is a senior. So obviously Junior you need to know, you need to conquer them first, and then you will get to the senior level later on. Now the first skill that we're going to go through is the ambiguous case of sine law. Now there are time to time where the whole configuration of the triangle is not given to you, only part of it, and then you actually need to figure out whether the given configuration will give you one or multiple type of different triangles. So let's take a look at this one very briefly. It's not actually too hard as long as you remember the sine law. There are two cases, and most of the time what's given to you in the question or in the scenario is where this angle is going to be given to you as the A or whatever the letter. It doesn't have to be A, it could be K, it could be Z, it could be T, it could be P. However, this angle over here is going to be given to you. And then what's going to given is the opposite side over there. So I'm going to actually have it something like this. So the opposite side A's length is going to be given. The hypotenuse or not the opposite side is going to be given to you as well. And I'm going to call that as B. And the opposite angle to that side is also B. There are two cases as a umbrella cases. And what I mean by is that the first case as A being greater than or equal to the other side. So the opposite side is greater than the other side. So in this case, if I draw it, let's say long enough like this, then we do have a triangle, right? We do have a triangle, and as we can see, A is definitely greater than B. Well, maintaining the angle A, there is no other way that I can create this triangle with an acute angle A unless I change the direction of the side A to the other side. However, then we're actually using the angle A being the obtuse, so that's not the triangle that we're intending. Therefore, in order for us to keep the angle A as an acute angle, this is the only one configuration that we can actually make. Therefore, if the opposite side is bigger than the other side, then there is always one triangle no matter what. You don't actually need to go through a calculation because there's no need. If the angle A was an obtuse angle, so for example, let's say if the angle A was constructed this way, then if the side A is bigger than the side B or the opposite side is bigger than the other side, then again you only have one triangle to be able to build like this, and this will be obviously angle B. Then you will ask me, what if in this case where the angle A is an obtuse, the side A, the opposite side, is shorter than the other side? Well, if that happens, then something funny happens actually. So let's say this is my A, and as you can see, the side B is longer than the A. Visually, we cannot form a triangle. If an angle A is an obtuse angle, then the only option for you to have a triangle is where the opposite side of the given angle is greater than or equal to the other side. So that's the first umbrella case. Second umbrella case is where your angle is acute, not an obtuse. Your angle A is an acute, and your opposite side is less than B. So let's take a look at this. If you have angle A and you have a side A over there somewhere, I don't know, so let's say that's A, and then your angle B and then side B. Visually, A is less than B. Then we have to think about this one very carefully. So when you deal with this, here then visually A is less than B. So in this case we don't know what type of triangle we're going to be forming because we really have to do the calculation to figure out. And there are three types. One is a two triangles, and the other one is one triangle. The last one is a zero triangle, meaning no triangle being formed. Therefore, what you need to do, since we don't know whether this is going to be a right angle triangle or not, we simply just move on to the sine law. So hopefully you remember the sine law formula. Let's take a look at what sine 90 is. So if sine 90, and that gives you 1, and if you try to find the other value that gives you 1 for the sine ratio, it actually is bigger than 180 in terms of the angle, but in triangle we cannot have anything bigger than 180, so that's not possible. So that means if your sine of an angle ratio after your sine law gives you the value of 1 as the ratio, then it gives you only one triangle, since that's the only one that gives you one value. Next one is then what if you have an acute angle other than or less than 90 degrees. Now then what you need to do is you compare that to, let's say, sine 150 in this case. So between the 30 and 50. Try to punch these into your calculator and see what you get. And I am pretty sure you're going to get 1/2 or 0.5 for the sine 30 and also for sine 50. As you can see, if you add the 30 and 150, they actually become 180. Therefore, these angles are yielding the same sine ratio, which means if you have a sine B ratio that is in between 0 and 1, so any, let's say, decimal 0 point something or any fraction that is less than 1, it gives you another type of triangle. And the reason is very simple, and I will demonstrate it on the triangle above here. These 30 degrees and 150 degrees actually are the angle B, since the angle A is given to you. And if angle B, let's say, is 30 degrees, this arm is a little longer, and if I swing it this way, it's actually going to go past through the bottom. And if I swing further, then it will actually land right here. Now, obviously, these two sides are equal, right? It's the same side that I just swung. So it is also 30 degrees over there because it is the isosceles triangle. Now, here then the triangle with the A, B, and C, or so angle A, opposite side A, and the other side B, is the triangle that I highlighted in green. And as you can see, the angle right there for B then, new B, is 150. And we have another obtuse triangle over there. As you can see, we then have two triangles for this case. And try to do something like this. What if your sine B ratio is bigger than 1? So let's actually try it. Can you do on your calculator sine inverse of 1.1 and see what you get? And you should be getting error or undefined or not a possible answer, because that means a sine B ratio or sine angle ratio cannot go beyond 1. Therefore, when you're doing the calculation after your sine law, if the sine B gives you anything bigger than 1, then there is no triangle. That means your side A is much shorter, or maybe too short. So the rule is very simple. For the two triangles, your sine B ratio after the sine law should be in between 0 and 1. For one triangle, your sine B ratio must be equal to 1. And then for no triangle, your sine B must be greater than 1. And you will actually see more clearly if we do the example. So let's take a look at the example. Now then, MPC 1, angle A is 60 degrees, side B is 10 centimeters, and side A is 7 centimeters. Will this form two triangles? Why or why not? So let's actually try this. We have a bottom over there, and angle A is 60 degrees. Sure, 60 degrees over there. And side A is 7 centimeters. I don't know, so I'm just going to contact it like this so that it visualizes as a triangle. However, we're not sure. Again, this will form a triangle or 2 or 0, okay? We don't know it. I'm just doing it to make it easier to visualize. Now, this is the side, opposite side of the 60, and obviously this is my side B, angle A and angle B. So use the sine law. Now, remember, sine law is sine of an angle, in this case angle 60, over the opposite side equals the sine of another angle over its opposite side, which is in this case 10. And do the calculation. All I need is to isolate the sine B. Therefore, what I will do is I will multiply this to the other side over there. So it will be sine 60 times 10, so divided by 7 equals sine B. And if you do the calculation, the value of sine B, the ratio, is then 1.24. So this means it's not going to form any triangle. Since 1.24 is greater than 1, therefore 0 triangle is going to be formed. Now this must be presented to your solution. Otherwise, if you just go from here to there, we need to know why there is 0 triangle. Now then, the MPC2, pretty much the same thing. We'll try that on your own.
A few moments later.
Now then, let's try this one. It says, will this form one triangle? Why or why not? So let's actually see. So sine 30 degrees over 100 equals sine Z 80. Again, you're just trying to figure out what the ratio for the sine Z is. So I multiply this 80 to the other side over there. 80 sine 30 degrees over 100. The sine Z equals, then you get 0.4. So then you may say, oh, so sine Z is then in between 1 and 0, therefore two triangles. You have to be very careful with this. Okay, remember from our umbrella case, I'll actually write this one again over there. If my side A is longer than side B, then we agreed that we can only form one triangle since we cannot swing this arm to the other side, creating an obtuse triangle, because the angle A given to us is an acute triangle, right? Therefore, hope you can see it, our opposite side is actually greater than our other side. So it is actually 100 greater than 80. Therefore, do we really do need this type of calculation? No. Okay, so be really careful with this. Since the opposite side is greater than the other side, it will only form one triangle. So hopefully you didn't fall for that trick. You may see those tricks on your test or quiz here and there. Therefore, you really have to be careful with this. Hopefully this was helpful. If this was helpful, please don't forget to hit the subscribe and the like button. I'll see you guys in the next skill. Bye guys!